formulas?
No, just whatever the, when I put it into the calculator or the solution.
Oh, you clicked it in my calculator?
All right.
Oh,
I don't know if
I wrote it down.
you guys can hear me because the mic not working.
Just.
Okay, it's C1 e to the PT over.
But I'll have it.
And then
E to
plus-
the what? E to the.
Yeah, yeah, and this equals to.
Hello. Yeah.
Where your speed is speed.
All right. So we're working on with homework 8, correct?
Yeah.
All right.
The only thing is, I don't know, he said he's gonna be adjusting because.
Okay, so that's
Well, we good.
homework. That's December 11. So when do you guys have that's next Monday?
Yeah.
When do you guys have the test?
Tuesday.
Oh, okay. So the 12th.
Here's one more lecture.
Okay. And he has one lecture, yeah.
Yeah.
He posted something on Canvas
Just recently.
recently. Yeah. He posted a, let me show you.
Another lecture.
I think so.
Really?
Yes, I got a notification. I'm having issues with Canvas. I'm not getting a lot of notifications, unfortunately.
You're not talking about, there was one from Friday.
I read something in
Maybe
regards
you.
of last presentation. Last something.
That might have just been me.
Oh, yeah.
But you
It says you posted.
But I can't.
You're using the symbol announcement for this.
What I'm confused because I don't see any files. I remember getting an email. Let me check my email. Yeah, the last thing is lecture 31. That's interesting. Let's see. Oh, look. So basically, as far as I know, we don't have the content for that homework yet, correct?
Well, we,
In class, he said he might he might make adjustments, but it didn't sound promising.
Sure.
That's just from my perspective.
No, I mean,
Didn't sound like.
you're Paul, you know.
He said.
You're trans.
What? Yeah.
You're trans. That's the reason you make so much money in the stock market. Deviations, volatility, stuff like that, price movement, you know what I'm talking about.
Yes, yes.
Okay, I heard something pressed. Let me see. No, I got something. CCN design, thermal, assignment graded, transport 8 hours, thermal.
what is this extra credit assignment friction?
I think you already did that. I was in class at some point. I don't know.
Remember doing, I was there for the applications of. Application of.
I think it was 2 different ones. But
Yeah,
I don't remember it.
I think I misread something else. My bad. Okay, let's go again. So assignments. What was it? 8. Okay, so what question do you guys want to work on?
we did A, I think you're okay with that one, right?
With 1?
Yeah, I mean,
Yeah,
sure.
question one. We were just kind of going through B.
B?
Oh, yeah,
Part B of number 1,
Okay,
and just kind of eliminating our terms and stuff.
okay.
The other
Let's start there.
Yeah.
Yeah. So you have the equation that you have like convection.
Yes, rectangular. The other
Okay.
thing is, I feel like we don't have a lot of assumptions here, so we know that they give us that a steady state.
Okay, let me get that here. 30.
Yeah. We have,
So now accumulation.
so we have the velocity Vy,
So Vy,
so I think that means we can say that it's only the direction of Y.
that's smart. Yeah, I like that. So you got your vector velocity and you have field Vy. Is there
I have to leave so. So this is really. But,
Yeah,
so we
okay.
okay.
So, yes, and then no convection, or no, there obviously is convection. It's a Peclet number before said that there was gonna be convection. Convection is dominant,
Oh, so there's convection. So you have Peclet number equal to?
10 or something, right?
Yes. Yes, because the Peclet number was the ratio between convection and what's the other one, diffusion?
Diffusion. So, but the other thing is, we have, it doesn't specifically say there's no reaction. So
But for this class, we can assume that.
yeah.
He
so
said
no
that
reaction.
in the first class.
Oh, that's right.
Yeah, sorry, Paul?
You're
So
correct, yeah,
Yeah,
said
but-
no reaction.
Convection wins.
based on the diagram,
No reaction, we said. Okay.
this,
Yeah, you can always assume that.
so then for the what concentration is a function of,
Yeah,
we just kind of assume that it's in the same direction as the velocity.
That makes a lot of sense, yeah, for sure.
But they
Why?
also, we're also not entirely sure because we haven't dealt with convection yet. And they don't specifically state if it's a function of certain parts here.
is the, we're like questioning where the flux, if the flux is only in the y direction, then we can only consider the y component of the concentration.
Mhm.
But there could be other directions of concentration and flux. In this
True.
question, so we don't know what it is. You
Based,
must see the question,
so let me read it. Based on the lectures, first time without reading it will be to assume that it's on the y-axis. Because that's what we have had. Basically, what is
right,
currently like
that's the trend.
working with
Yeah,
at this point in the class is when accumulation is
One-dimensional. We're doing one dimensional.
one dimensional. Yeah, exactly.
Exactly, so that's what it is, one dimension.
Yeah, I was about to get there, but yeah, definitely. Yeah, since you're getting only one dimension, I mean, you cannot work in other dimensions.
Wait, what?
No?
Okay.
Since we're only working in one dimension, we cannot work with other dimensions. Yeah, that was about, I was going to get,
You're gonna get the,
yeah, but
you
yeah,
got there,
yeah, no, you got
yeah,
smart boy.
okay. So then our
So we have this
equation is Vy
Vy,
times partial of the concentration of the species divided by, or with respect to y. And then
Yes.
it equals the diffusivity
Vij,
constant
right?
times the second partial of concentration with respect to y.
Like that.
yeah, so now,
And
This is
you,
where-
there's no accumulation because of steady state and we don't have any reaction. I like it, okay?
so
Yeah, so that's our equation, and
so
then we
now-
put it in the computer. And it gave
the
us,
computer?
I'm realizing now that.
we didn't know how to integrate it. Well, we think we have to
Oh, okay, continue.
we think we've used the pulse transform.
Oh, that's what he was getting to.
Yeah, that's what I'm not sure if we should. Cause also, so we haven't yet seen in this class where we've had,
That,
Convection at all.
convection. Cause that makes it like that term is normally zero on the left side.
No, on the left side, yes, and then it would be easier to integrate if we have the zero there, so.
yeah, or a constant.
Exactly, but this is a changing to partials, or it's a derivative.
Yeah.
But it's all, you can put it all with respect to y.
Y.
So that's like becomes a homogeneous,
That's true.
which is helpful.
So we're getting By goes to the partial. J, and then I can write this as this. Okay. So this is the same as. Yeah, here's what I can get a lot of funky math and
I'm so bad, I'm literally, this is my worst area. I mean,
so what we did in class is that he was talking about the change, correct? change of
Oh, well,
concentrations
that's. Can
with respect to some characteristic length, right? CL minus C1
you
divided by
cancel this
delta.
out or no?
That's exactly the other thing I was thinking of. It's basically the same change. The difference is that you have different constants to multiply to it.
Wait, no, because that's with respect to y, so it's like.
After you state your previous statement, not the one that you have. You can cancel out, and then you were about to.
I was
Go
just saying
somewhere?
you just cancel out, but then
Okay.
I was backtracking saying you probably can't because that is in parenthesis with the partial with respect to y, so it's not like, those are two not just random variables, right? Aren't they just, they're attached,
That's.
so I don't think you just cancel.
I mean, you're changing with respect to y while the y is changing. They're not necessarily. They are.
You can't just take it out.
Let's study it. You can just not cross that.
You can try it.
Remember, as long as you have an idea and you start working with it, you can get partial credit. And that's basically what we're trying to do.
Okay.
And that's gonna lead you to an answer. That based on your assumptions, you can be correct. For example, in exam 2, there are a couple of questions that there are some of you guys that approach it in a completely different way. For I think question 1, the humans versus the mass problem. That's correct too. If you go through that rabbit hole and all the statements are correct, you cannot say that it's wrong. So technically,
There should be one right answer in this class, period. And there should be a best route to get there, and we should know the route, because it should.
I don't
be
like
this
that.
route.
I don't like that because it's
No.
not pure math.
It should be.
It should
It should
be.
be regular, like, we're estimating values, there should be line, like in Orgo, it's always like there's lines in the sand where like,
That's true.
if it's above this value, you know what to do in that scenario. Whereas I
You wanna go with the canceling?
Sure,
Let's cancel.
but then, okay,
Uh-huh.
so we'll just cancel them,
Yeah, that's that work.
but then you
Uh-huh.
get
Uh-huh.
y equals dij. Right,
Yeah,
and they don't equal each other, they're just random constants,
that's true.
so.
I think what you would have is, yeah. This constant was, yeah, okay. So you were,
So
yeah,
we're
we
just
can put up in there.
Okay. I like, okay, I just don't think that's right, so.
So you were saying that Laplace transform.
Yes, I don't know anything about that, but it was on the formula sheet. Well, I know about it. I did it in DBQ, but it's like.
Yeah, I
been a
did it
while.
too.
You can write it out.
No, I think what we have to do is there's a
Go for it.
technique for solving homogeneous second order equations.
Okay,
Because what we can do is before you separate it out. If you
Like here?
move everything over to one side,
Right.
okay, let's do it.
so
Let's work here. So by partial of cy, y minus bij, and then we have that like that.
yeah,
Okay.
so. I had it in my notes at one, I tried pulling up my notes, but what we're supposed to do is normally we have like. Constants, I mean, these are still constant coefficients.
Y,
We're supposed
by and dij.
Yeah.
Yeah, they
So
are.
we're supposed to do it like the characteristic equation to see if we
Okay.
can remember that.
Yeah.
So
You
that's
can pull that something out,
So let me.
and then you get like
Yeah,
like-
so ours, I guess, ours would be.
I like where you're going.
Dij,
I vaguely remember something like this in this class.
Dij r squared minus By r is equal to 0,
Yeah,
and then. We're supposed to find the roots of this.
yeah. So you get, so we're left with is. Wasn't like this, like you factor out this term,
Well, so
and then you.
the characteristic equation is let me pull it back up here.
What formula sheet did you see the whole stuff?
No, I didn't. I was looking through my DQ notes. So,
I think it was something like that, you factor out.
yeah, so your characteristic equation is the coefficients, like,
Okay,
so like if it was, so it would be Vy times, oh wait, I have that.
A double prime.
I
right?
subtracted
B,
Vy from, I just did a Vy minus. Yeah, so then our characteristic equation is Dij times R squared,
oh, okay,
Dij times R squared.
Yeah.
And then minus Vy
or,
times R equal to
equal to
0.
zero,
So
okay.
now we're supposed to solve for our roots.
and basically you factor out, right?
Yeah.
That,
so then
okay, that was
that's
what
where
I
I
was
that's where I'm
referring
going.
to. So you
Oh.
get Dij, not a problem, R minus Vy times R is equal to 0, right? So the first one that you get is R equal to 0. The next one is that R is equal to Vy minus Dij.
Oh yeah, that was the A over B, remember that you did that?
Something looks right, it's hard to see. Yeah.
Yeah, this was, remember we did it. Okay.
Dij times R.
So those are two roots.
Vy divided by Dij, right? Vy.
Oh, so you factor that out, and then you have R.
So now our representative, because now we have our homogeneous equation is gonna be Ci of T is gonna be,
Okay.
the formula is that it's a constant
So,
times,
so it would be negative Vy.
no, so here, I can maybe, so we have our here. This is our general solution. The format is C1 times E raised to whatever these roots are.
Oh, okay.
So now, and our
Okay.
two roots are 0.
It's coming back to me. A little bit.
Yeah,
Alright,
so
so you get e to the,
How do you get R equals Vy?
it'll be a constant.
Oh, in there. Oh, it could equal, yeah.
It'll be a constant times E raised to our first one is, I guess, gonna be 0.
so,
But the only thing is, I'm not sure is this becomes a function of time, no? Because they have a variable T.
Yeah, C of T, it should be C.
Oh,
Oh, wait. Oh, D, it
but in
should
our
be,
case, it's Y, right?
oh, so they're constant, so it will be y.
So
Because
it's,
in if you're pretty sure
that
the
should be Y.
independent,
Y,
your
Vy
independent variable
times
was
Y.
t,
in our case, it's gonna be Y.
correct?
So then our first root is 0 times Y. So
I
that's,
like that, yeah, what's like t, where's t from?
yeah, that's.
Got you, alright. 0 times t, which means this cancels, well,
A.
cancels out to
So
one.
the concentration with respect to Y, or in.
Yeah,
T.
it's Ci is a function of Y.
Function.
Y, okay, that makes more sense.
Then plus B.
So we're talking about space, yes, yes,
Yeah.
yes, okay.
Yes, yes.
Good.
Then B times E raised to the Vy.
Oh, this is not e, it's just a constant.
Yeah.
B
So,
to the 0
but there's a
times
constant in front. We're supposed to put
Oh, by?
whatever, it's just
Oh,
arbitrary.
I, okay,
So that's why I did A, but it'll go to, A times 1, right?
okay,
Then our next one is B times E to
E
the,
to this,
and
right?
then our second root, yeah, times
So
Y.
by over
That's
dij.
what, wasn't it, I tried plugging this into a differential equation calculator. This is the answer.
Oh, yeah,
Yeah,
look
so,
at you.
so then,
E to the, oh, yeah.
And now, based on our assumptions or the ones that we can,
our boundary conditions.
boundary conditions,
Yeah.
sorry.
Yeah, so
We
then
can get A and B.
our final,
Yeah. So our final will be like C, well, the general, C will be A plus B to the By Dij Y. So these are our general
That's the general.
solution. Way to go, man.
Very good. We need to add these things. Right? We want a specific solution? For part B. Okay, I have to go.
Yeah,
Right.
there you go.
Thank you.
are you gonna go to
Yeah, I'll be there as well.
I'm gonna keep doing it, see, it was sucked up, he goes, you guys don't have to worry about this problem after all, I shall say.
I don't think it wouldn't be like time wasted, I,
Yeah.
Thank you for passing.
Yes. Huh?
Thank you
Good to
for
see
coming.
you. Yes, sir. See ya.
Take care.
We only have to see where, how far it is, fortunately. I submitted my homework last night, 11:59, so I'm not doing that again, I'm getting the jump to this one. So for part B, please keep the equation in variable form. Yeah, I think it just wants us to plug in our, what's it called?
For part B?
We gotta plug in the BCs now.
Oh, okay, for part B, right?
So,
Can you say this part?
yeah, so
what do we have as VCs? So we have VCs.
these are a little bit less. Okay, so we have first that. Assume that the back,
Oh, you know what BY is? That's helpful. DF is DIJ.
where you see the,
The end of the
oh, yeah,
of the
yeah,
first.
yeah, I guess instead of writing it as the effective,
Yeah, fine. Okay.
Yeah.
So
so, okay, I know our first boundary condition is that. Assume the bath above the tissue is sufficiently large so the concentration remains at 0. So I guess that's.
so
CI of y equals infinity. Is that what that means?
yes,
Equal to 0?
yes. So
There you go.
so
Assume the bath.
PI of y equals infinity is equal to 0. Yes, that's a binary condition for sure.
And then CI at y equals. But what about L? Shouldn't L be a part of this?
Let's see. You have 0, L, and then the bath. And you know that the drug is coming from bottom to top, right?
So yeah, we at CI of y equals 0 should be equal to C0, right?
Z0.
C0.
I mean, the performance goes before select a similar lymph node side of you want to use delivery safe flow again through a 300 mils lymph. There is CO, okay.
I guess no, we don't need that because we know what.
Go for it.
So we don't know what the concentration is at y equals L because in part C we're trying to plug in to find that.
Okay.
So I think those two boundary conditions should be fine.
So Y0, that's the one that we know, which is the initial condition.
Yeah, C0. Right.
Okay.
Y equals 0 would be C equals 0.
And also this is time equal 0.
We don't have to worry about time, I don't think.
No.
No, because it's steady state.
Oh, never mind. So we get this, right? So we get the boundary conditions are that an infinite is 0, and when y is equal to 0 is the initial concentration. And let's see. So let's go with.
How would we, let's say we were to plug in infinity for y, we would get e to the infinity.
That's right. That's what I was looking at.
I don't know if that's it.
Is it? Let's see if we can write this another way. So, towards the negative Dij, negative Dij, you're looking for R. Yeah, essentially you get the flip version of this. You don't get a negative. Let's get to Y. But it's just, do you know if that's to a negative power?
Which one?
When you calculate this, guys?
No, because
When you're figuring the roots?
so
Not necessarily the roots themselves, but actually like this form. of the equation.
So
This one.
that's the that comes from, that's a general solution for homogeneous equations?
And it's not negative, like the exponent.
No.
Okay.
Let me see if this is in.
Hey, but that says something. That says that Cij at y equals infinity is going to be equal to a plus infinity, which is then equals to 0.
I feel like
So from there, I guess you can assume something. Maybe that b is equal to 0. Does that
Maybe.
make sense? That given that that term cannot be equal to infinity, therefore b, the coefficient is equal to 0. That's an option. I'm saying that's correct.
Yeah, I see.
Maybe
Well, I think it's how I'm interpreting it. It says assume the bath above the tissue. So that's when y is greater than L, which is the thickness of the tissue,
yes.
is sufficiently large such that the concentration in the bath Cb remains at 0.
So that's what that's telling you is that Ci of y greater than L is equal to Cb, which is equal to 0.
Yeah,
That's different.
remains at 0. I don't know why Cb, why they give us Cb. I don't know if we're supposed to say at y equals L. It's greater than L.
Yeah, no, it's greater than no. So in that case, how can we write this? We can write that as something greater than L. So y greater than L. But when we plug it here. But what if we do it like Ci is equal to L plus some constant K.
Let's see, but then in parts, we could do that, but then in part C, we'd have to plug in. Like more, because we're trying to get an actual value out when y is equal to L. We know the distance of L, but we don't know what. We would be picking an arbitrary distance for K.
Yes, we would. Let's keep thinking. So
Oh. Wait, what's the graph of? The graph of e to the x goes to 0 at infinity.
really?
Wait, which one am I looking at?
No, it's exponential.
E to the
growth.
negative
That's
x. E to the-
yeah, that's the reason I was asking you if it wasn't negative, because if it's negative, it doesn't matter, it goes to 0.
Solve the roots, right?
It's is that it?
I'm just trying to see if I solve the roots, right? Then maybe R was negative, that would be.
Yeah, from what we got, that's.
I'm not sure. I have to call though. I'm gonna go to the professor's office. I was asking about the grades. Have you ever been to where his office is?
Yeah, we're fine.
It's in the very nice engineering building?
Yeah.
Right next to the, okay,
I think it's the third floor.
490, is that in here? Third, fourth floor. It says 490 worth of engineering.
Yeah. So you go, well, from ground, you go up to floors.
Alright, so I can ask you about the grade. And I'm gonna see, I might wait to see how class goes on Wednesday.
Yeah, because this,
I don't know that, so that general solution seems right to me. I think maybe the boundary condition. If I have time, maybe I'll ask him real quick if we're gonna get to something like this. Cause I'm gonna ask him if we're gonna have convective. Where we have convective terms in our equations, and if we do, then I'll know to keep going with this.
this is a point, like, for example, if you were to have something in the test. And you are where you are right now, this is a point that you can start like